everyone, this is the second video of chapter 1, powers and root. In this lesson, we will talk about how to write a special kind of quantity. For example, let's say you're writing 2 times 2, which is simple. However, what if I want to write this 100 times, where that could take forever? But would you believe if there is a quicker way that I could write 2 times 2 100 times in 3 seconds? The first vocab that we are going to learn is what we call powers. The powers, or they call indices, this is the plural of index, are a convenient form to use when writing a specific kind of quantity. Indices tells you how many times to multiply a number by itself. For example, if you have 6 with a 2 on the top, little small number, this is telling me that you're multiplying 6 2 times. So in other words, if you have 6 times 6, you should get 36. The number 6 is what we call base. This is on the bottom of this form, so we call this one as base, where 2, the small number, is called index or power. The number 6 with the 2 on the top can be read as 6 raised to the power of 2, or if you have a second power, we also call it 6 squared. Likewise, if the power was 3, then it has also special name. It's called cubed. After 3, it doesn't really have special name. So if it was power of 4, then it's just 4th power, 5th power, 6th power, and so on. So if you want to represent this 2 cubed, that is telling me you're multiplying 2, the base is 2, 3 times. The common mistake is that students tend to multiply these two numbers so that they get 6. Which is not correct, because if you multiply 2 3 times, 2 times 2 is 4, times 2 is 8. There's another video regards to powers if you need more explanations, which I will also include on the link below. Here's another example. What if I say 5 to the power of 2, or we call it 5 squared? This means it's not like 5 times 2, but this simply tells me you have 5 2 times in multiplication. So 5 times 5, I should get 25. What if I want to know what number do you need to multiply 2 times to get 25? This is something that we'll focus next. The opposite of powers are roots. If 6 to the second power is 36, then the square root of 36 is 6. So for example, if you use the symbol, it looks like a little V shape, and then at the end it has a little tail. If you write square root of 36, this is asking me what two numbers do you need to multiply to get 36. In this case, it has to be exact same numbers. So if I had 6 2 times, I would get 36. That's how I know square root of 36 is equal to 6. Well, so then what would be the name of opposite of cubed? In this case, if you want to find the opposite of cube, this will be cube root, with 3 should be a little smaller in front of your symbol of square of roots. After 3, it doesn't really have a special name. So like I said, after you have cube roots, it's just 4th roots, 5th roots, and so on. Here's another example. Let's say you have cube root of 8. If you have cube root of 8, I'm asking you what number do you need to multiply 3 times to get 8? In this case, n has to equal to 2, because these has to be all same numbers and you have to multiply 3 times. Therefore, if you have cube root of 8, that is equal to 2, as you see on the bottom right here. Let's look at some examples. Before number 1, let's do number 2 first. Express each number without indices. In other words, use base and exponents to simplify this in one number. So if you have 4 squared, that is telling me you have 4 2 times. So 4 times 4, I should get 16. If I had 11 squared, 11 times 11, I should get 121. This time you have 4 cubed. So this is telling you what is the number when you multiply 4 3 times. 4 times 4, I get 16. 16 times 4, I get 64. Next, 7 squared, which is not 14 if you were thinking about that number. 7 squared is asking you what is 7 times 7. I get 49. 10 cubed. What happens if you multiply 10 3 times? Since these are power of 10, so 10 times 10, I get 100. You have 2 zeros, so I should get 2 zeros. 100 times 10, you have total of 3 zeros, so this should be 1,000. 5 cubed. 5 times 5, I get 25. 25 times 5, I should get 125. 2 to the 5th power. So I don't know if you notice, I've been writing numbers that you need to multiply, because sometimes when you're multiplying too many numbers, it does help. So if you have 2 5 times, or sometimes I don't have to write it down, I just use my fingers to count. So 2 times 2 is 4. 4 times 2 is 8 times 2, 16 times 2, 32. 3 to the 4th power. So 3 times 3 is 9. 9 times 3 is 27. 20 times 3 I should get 81. So this one has to equal to 81. Let me go back to number 1. They were asking you list the perfect square up to 225. So I didn't explain this earlier, but what does it mean by perfect square? What kind of squares would be called perfect? So you know the squares means you are multiplying a number 2 times. What I'm asking is, there are certain numbers, let's say if you have integer with n is equal to 1, 2, 3, and so on. When you plug it in these numbers, there will be certain numbers what we call perfect squares. So if I plug 1 in here, 1 squared would be 1, 2 squared would be 4, 3 squared would be 9, and so on. These are the examples of perfect squares. The numbers that if I take a square root of this will be still an integer. Here is non-example of perfect squares. If you had square root of 3, are there any numbers when you multiply 2 times I should get 3? If you're thinking yes, you might be thinking about decimal. However, there is no number that when you multiply 2 times to get 3 as an integer. So this is not an example of perfect square. If you continue to do so and you have to go all the way up to 225, the next number, 4 squared, will be 16, 25, and then 6 times 6, 36. We did this. 7 squared, I got 49. 8 squared, which we didn't do it yet, so 8 squared is 64. 9 squared, 81. 10 squared, we did, well, that was cube. 10 squared, I get 100. And we still need to keep going all the way to 225. So you can do it on your own, and let me know if you get stuck by leaving a comment. Number 3, evaluate these square roots. So if I just see the symbol, it tells me this is a symbol of square root. If you had cube roots or fourth roots, they should have a number in front of your root like this. So in this case, what 2 numbers do you need to multiply to get 9? And remember, they has to be exact same numbers. In this case, this was 3. So this relates to your first question, the perfect square. The 9, an example of perfect square. So that's how I know. Square root of 9 is 3. 81, is that also a perfect square? The answer is yes. In this case, I got 9. Square root of 100 is 10. 324. Oh, this is a little bit difficult. So n times n, a same number twice, you have to get 324. I know when I had 15 times 15 was 225. What if I had 18 times 18? In this case, 8 times 8, 64. 8 times 1 is 8 plus 6 is 14. And then I have 8, and 1 times 1 is 1. In this case, I got 4, 2, 3. Oh, so this is an answer. The square root of 324 is equal to 18. What about 6,400? The easier way for me is get rid of these double zeros, because I know 10 times 10 will get 100. So let's just think about square root of 64. 64 was a type of perfect square, so I know if I had 8 two times, I will get 64. So what if I do 80 times 80? Will I get 6,400? The answer is yes, so I know this is the 80. Square root of 225, we just did it in number 1. This was 15. And for the same reason, you can do 2500 in square root. That should equal to 50. Here's an interesting symbol. You have square root. Inside, you have 4 square. Didn't I say square root and square, they are opposite to each other? So if they're opposite to each other, think about the inverse operations. Square root and square, they will cancel each other. So all I get is just 4. And here's another way that you can do. If I simplify 4 squared, that is equal to 16. So what two numbers do you need to multiply twice to get 16? The answer is still 4, so that's how I know my process was proved. Number 4, evaluate the following roots. So now that you're going to deal with more than just squared. Remember, the other roots are still the same way as the square root. Only difference is if I had a cube root, I'm trying to think what 3 numbers do I need to multiply to get 27. And remember, they has to be all same. So in this case, if I had 3 times 3 is 9. If I had 9 times 3, I get 27. So this is 3. What 3 numbers do you need to multiply to get 125? The answer is 5. If I had a number 4 times to get 16, I know my number has to be small. So for example, if you're thinking about 4 times 4 is already 16. So I know for sure that that wouldn't work. So guess a smaller number than 4. I know that 3 wouldn't work because 3 times was 27. It's already over. What if I try with the 2? So 2 times 2 is 4. 4 times 2 is 8. 8 times 2, I get 16. What number do you need to multiply 50 times to get 1? The answer is 1. 1 times 1 times 1 times 1, you will always get 1. Today's lesson was very short. However, if you need more examples, like I mentioned, I will include another video link on the bottom of description so you could explore more. However, if you need anything else, please let me know by leaving a comment. Thanks for learning with me.